Hey young man, Mr. Maldonado here. Alright, so we're going to be talking about minerals. We're going to find out two things. One, what is a mineral? And two, how do we actually identify minerals? Because sometimes minerals look exactly the same, so what test do we run to figure out exactly which mineral it is that we're working with? Alright, so let's start with what is a mineral? So remember, everything I do here and write down, please make sure that you write down on the graphic organizer I gave you with your vocabulary words. So mineral. A mineral is a naturally formed inorganic solid that has a specific chemical formula and repeating three-dimensional structure. Alright, so you might be wondering, what is inorganic? What does that even mean? So let's write down what inorganic means. Inorganic means that it is not made from the remains of plants and animals. Meaning, when plants and animals die, sometimes our remains, they go into, different cycles again, and are reused for different things, but minerals are not made of that. They're inorganic, so they're not made of the remains of plants and animals. Alright, one of the tests that we can look at in order to identify a mineral is the color. Now this one right here is very simple. The color of a mineral's surface shows. That's the color, okay? When we're talking about color, we're talking about the actual thing that you see, what the surface of it shows. So just as a quick example here, I have a ball here on this page. Very simple, just look at the surface. What color would this ball be? What would you say? Exactly, you would say that the color is red. Very good. So now we're going to look at three different minerals, and we're going to try to see if we can figure out what the color of those three different minerals are. Alright, so let's look at mineral number one. Mineral number one over here, this is a diamond. Alright, so by looking at this, what can we say about the color of this mineral? I know what you might be thinking. You might be saying, oh, well, it's clear. Yeah, well, clear isn't a color. So what would we say if clear isn't a color? Great job. We would say that this one is colorless, meaning it doesn't have color. Let's look at the second example. This second example down here at the bottom, this is a mineral called jasper. By looking at this, the surface of jasper, what color would you say it has? Great job. It's kind of like a brownish combined with yellow, right? Kind of like multicolored. Now, jasper sometimes is multicolored, but instead of having these colors, it could also be just all yellow, orange, it could be red, it could be green, it could be blue. Alright, so color sometimes isn't the best test because it can be so many different colors, and that can match the color of another mineral. So we have other tests that we're going to be looking at later on. Let's look at this third mineral over here. This third mineral over here is called cuprite. So what color would you say cuprite has? Exactly. This one is kind of dark gray. But just like jasper, cuprite isn't just dark gray. It can be red, it can be maroon, it can be a purplish red, it can be a reddish black. So it has many different colors. And I also forgot to mention, for a diamond, even though the one we see here is colorless, it can also be white, it could be yellow, it could be brown, it could be gray, it could be black. So see, minerals can come in all different colors depending on the environment that they're in. So color is one test we can look at, but not the best one. The next test we can run is called streak. So the streak is the color a mineral leaves in powder form when it scratches something. So pretty much when we're testing the streak of a mineral, we have something known as a streak plate. And what we do is we scratch the mineral across the streak plate and it leaves something. It leaves powder. So the color of this powder is the streak. So let's look back at those same three examples that we saw, the diamond, jasper, and cuprite, and see if we can figure out what kind of color streak they have. Alright, so starting up here, we have our diamond again. What color do you see the powder that the diamond left? Great job. So diamond would have a white streak. Now, what do you notice about cuprite over here, about its streak? Exactly. It's also white. So the good thing here is that if, let's just say, the diamond was white and so was cuprite, could we figure out exactly which one it was just by looking at the streak? No. So we have other tests that we can run, but streak is actually one of the best ones most of the time. Now let's look at this last example down here of jasper. Look at the powder that it left. What kind of color streak would it have? Great job. The color streak right here that jasper would have would be kind of like a brownish red. Let's look at another test. The luster test. Now this is something that you should be very, very familiar with because we've talked about luster when we talked about metals, nonmetals, and metalloids. So here, in order to figure out the luster of an object, it's the way the surface of a substance reflects light, and we've talked about that. So we've talked about two different types of luster. We've talked about it having a lot of luster, so being shiny, which would be for your metals, so metallic. We've also talked about the opposite of shiny, so not shiny, which means very little luster, which means it's dull. But when we talk about minerals, we don't just look at super lustrous and the complete opposite dull. We have things in between also. Sometimes the luster of a mineral can be waxy looking or greasy looking. Kind of like wax paper that you use like when you're making cookies and stuff, so waxy. Kind of like the candle, alright? Another one that we can look at is kind of pearly. So the way pearls look. And another type of luster that we can look at is something known as being vitreous, which means it's kind of glassy. Now, when I say glassy, it doesn't mean that it has to look like glass, like completely clear, but it just kind of looks glassy. So let's look back at the three minerals we've been looking at and see if we can figure out the luster for those. Alright, so again, let's start up here with our diamond. By looking at the diamond, what kind of luster do you think it might have? Alright, so this one is not glassy actually. This one right here is kind of greasy. Oops, I misspelled greasy. Let me fix that. We don't want any typos here. Greasy, there we go. What about if we look at jasper down here? What kind of luster do you think jasper would have? Do you think it's more on the shiny side or the dull side? I would say it's kind of in between. This one would be what we call vitreous or glassy. That's what I mean by kind of glassy looking. Alright, so let's look at the last mineral that we have up here, which is cuprite. What about this one? Do you think it's more on the shiny side, so having a lot of luster like a metal, or the complete opposite, dull? Or is it kind of in the middle? What do you think? Very good. This one's kind of in the middle also. It's not super, super shiny. It doesn't reflect tons of light like a metal, but it still reflects some light, kind of like a metalloid. So this one we would say is, kind of like submetallic. Let's look at another test. Alright, so this one right here, this one's kind of tricky. I mean, even for me, I'm going to be honest with you, it's kind of hard sometimes just by looking at a mineral, so you have to look at it really, really closely. But we have what we know as the cleavage or fracture test. So, when a mineral breaks on a straight line, it has cleavage. When a mineral breaks and ends up kind of jagged, it has what we call fracture. Now, for jagged, it means kind of bumpy. So if it's not very smooth at all, it's more bumpy, it has a lot of spikes coming out of it and things like that, that's when we say that it has a fracture. So let's look back at our three examples of the minerals and let's see if we can figure out whether the minerals have cleavage or have fracture. Alright, so let's start right here by looking at diamond. What do you think the diamond has? Do you think it has cleavage, so it kind of breaks on straight lines? Or do you think it has fracture, meaning when it breaks, it leaves it kind of jagged, kind of bumpy? Alright, so this one, it's kind of in the middle. Alright? But for our purposes, we're going to say that this one has fracture. When we're talking about cleavage, we want more of like those cube type shapes. Even though that one doesn't look exactly like a cube, but pretend the lines are straight. Let's look at this one down here for jasper. Now look at this one. Is this one kind of bumpy? What do you think? Look at this section right here. That's pretty bumpy. It's bumpy right here. It's bumpy here. So would this have cleavage or fracture? If you're not sure yet, go back, rewind the video a little bit, look at exactly what the difference was between cleavage and fracture and see if you can figure it out. Alright, so because of its bumps, jasper, we would say has fracture. And let's look at the last example we have here, which is cuprite. Alright, so again, do you think it breaks on straight lines, which is cleavage, or does it break and leave it bumpy? So it doesn't break on straight lines, meaning it has fracture. Do you see any bumps? Yeah, I see a bump here, I see bumpy here, look kind of bumpy there, kind of bumpy there. So this one, would it have cleavage or fracture if it's kind of bumpy? Great job. This one has fracture. Awesome. Let's look now at the very last test we have. We have a test known as hardness. Hardness is a measure of scratch resistance. Okay, scratch resistance. This tells how hard a mineral is compared to others. So we're not going to look too much on hardness right now because we're going to focus more on that in the actual classroom itself as we're looking at different minerals and trying to figure out the hardness, which ones are harder than others. But just to kind of give you an idea, one of the ways we test the hardness is by using glass. Now, some minerals cannot scratch glass, meaning that if we rub the mineral on the glass, it will not leave a scratch on the glass. However, if you try to rub the glass on the mineral, then the glass will leave a scratch on the mineral. Then you have other minerals that are harder than that when you do rub them against the glass, it'll leave an actual scrape or a big scratch on the glass, and those are harder ones. So pretty much that's how we deal with hardness, alright? We have a scale, it's known as Mohs, so write this down because it's going to be very important. It's known as Mohs hardness scale. Whoops, I'm about to misspell that again. Another misspelling, sorry about that. Mohs hardness scale. And what this one has, it pretty much gives you 10 different minerals from being the hardest at number 10 to the least hard at number 1, and how we tested to determine the hardness. And with that scale, we can kind of put other minerals in between there and figure out around where their hardness level is. Alright guys, so thanks for watching, young men. I hope you understood a little bit on minerals. If you didn't, don't worry. We're going to be talking more about this in class, so we'll definitely be able to get this down. Also, I found a lot of the information at minerals.net. So if you want to get more information about minerals and all the different kinds, because there's a lot of them, you can always go to minerals.net and you can find a little bit more information about all the different minerals that we have.